So in this lesson, we're going to be talking about Lewis dot structures. By the end of this lesson, you should be able to draw the Lewis dot structures for different elements and the Lewis dot structures for different compounds. So what are Lewis dot structures? These are things that show the valence electrons that are around an atom. And if you remember, valence electrons are electrons that are in the outermost energy level. You don't focus on anything that's on the inner levels. It's just going to be everything in the outer level, like these 3 electrons right here in this aluminum model. But how can we figure out how many valence electrons each element has just by using the periodic table? Well, one thing you can do is you can look at the group number. Let's look at group 14, for example. All you have to do is remove the 1, and that tells you that you have 4 valence electrons in group 14. Well, on your periodic tables, you should also have it's like 1A, 2A, 3A, 4A, 5A, 3B, 4B, 5B. Basically, all the valence electrons that you're going to find are going to be in that A level. So you just remove the letter. For group 14, it should be 4A. And you are going to remove the A. And that 4 tells you how many valence electrons you have. Now let's count some valence electrons for different elements listed here. Let's look at calcium. Calcium is in group 2, atomic number 20. So if it's in group 2, that means it has 2 valence electrons. I shorthand valence electrons with a VSE, which stands for valence shell electrons. If you want to write out valence electron, that's fine. You do not have to. What about potassium? Potassium looks like it's in group 1 with atomic number 19. So if it's in group 1, that means it has 1 valence electron. What about oxygen? Oxygen is in group 16. Let's remove the 1. So now we're left over with 6, which means it has 6 valence electrons. What about sulfur? Sulfur, also in group 16, so that means it also has 6 valence electrons. So this picture on the side here, I have linked in Canvas for a reference. It helps you see the placement of each group and how many valence electrons each group is going to have, and helps you really make that connection. So looking at calcium, we see that we've already figured out it has 2 valence electrons. It's in group 2. It goes down in this group here. What about oxygen? Oxygen, 6 valence electrons, group 16. Well, it's going to go there in that group. So looking at their placement on your periodic table, you can also find their placement on this picture, which will help you also navigate the valence electrons a little bit better. I put this in here as a reminder just to help you bring everything that we just talked about together. So figure out what group your element is in, whether it's in group 1 or group 16. And that'll tell you how many valence electrons that element has. And when we're doing Lewis dot structures, all we're focused on is the valence electrons. That is completely different from the element models that we were drawing. This time, we just want to know the outer electrons. We don't care about anything else. So let's review the octet rule. We did talk a little bit about it in bonding, but we're going to be using this a lot in this lesson, so I figured I would give you a little bit of a refresher on it. Atoms, they bond to each other in order to have 8 valence electrons each. So each atom wants to have 8. There are 2 exceptions to the octet rule, though. We have hydrogen and helium. If you look at your periodic table, hydrogen and helium are in a period all by themselves. It's just them two. And that is because they only need 2 electrons to complete their octet and be happy. They only want 2. So that is why they're separated from the rest, because they don't need 8. They need 2. So how do we draw these Lewis dot structures? Well, the first key is going to be to write the elemental symbol. And then we place 1 dot around the symbol for each valence electron we have. Doing this up to 8 dots, and 1 dot will equal 1 electron. What if I told you let's do carbon? Carbon is in group 14, so figuring out how many valence electrons it has, we remove the 1. That means it has 4 valence electrons. So let's do this. We have to start with the symbol for carbon. The symbol for carbon is C. And now we're going to draw 1 dot at the top. We have 4 valence electrons, so we can only put 4 dots around C because 1 dot equals 1 electron. So now we're going to rotate around the symbol in a clockwise fashion, drawing 3 more dots so that we have 1 on each side. All right, so now it's going to look like this. And the reason we put 1 on each side first is because if you've ever tried to put the negative or positive ends of a magnet together, you notice that they repel each other and you can't get them to push together. No matter how hard you try, you can probably get it, but if you let go, they're going to go flying in opposite directions. That's how these electrons are. They all have a negative charge, and they want to be as far away from each other as they possibly can. So this makes all of our electrons as far away from each other as possible. Let's try to do some more Lewis dot structures. If you want to try these on your own, I do have 4 of them. You can pause this, work through it, play it again, and make sure you got your answer correct for all of them. 1 of them, that is completely up to you. So let's start with nitrogen. Nitrogen, the symbol is N. Remember, first step is always drawing the elemental symbol. Now, we need to figure out what group nitrogen is in. Well, nitrogen is in group 15. Remove the 1. That means this has 5 valence electrons. All right, now let's put the dots around our nitrogen. Remember, we start at the top with 1 dot, working our way clockwise until we fill all of our electrons. So we've got 1. Now I'm going to put 1 on the right side here. 2, 3, 4. So I have 4 valence electrons, but I need 5. So now I'm going to go back up to the top and put this dot right next to my first one, because we can have 2 dots on each side. Let's try the next. What about boron? So boron's symbol is B, and it's in group 13, which means it has 3 valence electrons. Starting at the top, we need to put 1 dot for 1 electron, working our way clockwise, fill it till we've got 3. That's what it should look like. So now let's try argon. All right, so argon is in group 18. That means it has 8 valence electrons, which means its octet is full. Argon does not want to bond with anything. It is happy the way it is, which is the same with all noble gases. If you remember from the tour of the periodic table, noble gases are unreactive. That is because they have 8 valence electrons, and that's all they want. So let's write AR for our symbol. and fill in our 8 valence electrons. Starting at the top with 1, working our way clockwise. All right, now I have 4. Next step, making each one dot into 2. So we're going to put 1 here, 1 here, 1 here, 1 here. So that is what your argon should look like. What about hydrogen? So I told you that hydrogen is an exception to the octet rule. Hydrogen only needs 2 electrons to be happy and complete its octet. Well, hydrogen's in group 1, so that means it has 1 valence electron. Doesn't have 2, but we're going to draw it like that.